Thanks everyone to coming for another OWASP specific meeting. We've also got some people from OWASP Bristol and OWASP Dorset, our sister groups, with us tonight. So in a moment, I'll be introducing you to our speaker, who'll be talking about securing your machine learning solutions and protecting your models. But first, if I can get the slides to work, a bit about OWASP. Most people already know we're the Open Web Application Security Project, international non-profit foundation working towards improving the security of software. You probably know some of our major flagship projects like OWASP ZAP and the OWASP Top 10. We have many more projects. We have 200 chapters worldwide, thousands of members, including you guys, and we produce articles, methodologies, documentation tools, etc., and I'll give you some links in a second. So tonight's agenda, I'll talk about some upcoming events, and then we'll go to the talk. And Phil said that he's happy with Q&A throughout. If you're new to Jitsi, if you wiggle your mouse in front of the Jitsi, a little menu will pop up at the bottom, and you can just type into the chat or raise your hand if you want to speak, and one of us guys will take your questions. Actually, isn't it better if we just, do you want to be interrupted, Phil? I know that it could affect the flow, but is that right? If people just jump in with a question?
You can jump in with a question. That's I'm happy with that.
Cool. All right, we'll do that. We'll see how it goes. Okay, so upcoming events. I finally got around to putting a few in meetup. So we've got, I think we broke a record this time. We've got 3 for May. We usually aim for about 2, but we're trialing our Fight Club, which is going to be an interactive sort of ethical hacker session. That is, I believe, the 24th. Obviously, we've got this talk today, and then on the 17th, we have Coralogic coming in to talk about Log4j shell. Is it, Martin? I believe so. Anyways, anyway, so if you go to our meetup page, you'll find more information on upcoming meetings. Also, feel free to subscribe to our Twitter and YouTube channels. Guest talk this evening. Phil Basford is one of the Ipswich AWS user group leaders. He's an AWS expert with many certifications. I think more than 12 now, is it, Phil? Yeah, going for the record.
12, it is 12. Yeah.
Is there any left? Or have you got them all now?
There's one more. They released a recent one in April, a new one into SAP, which I haven't got.
See, am I right in saying you're an AWS ambassador now?
Yes, that's correct.
Yeah. Yeah, and as well as that, he's a community contributor, speaker, blogger, open source contributor, subject matter expert on machine learning, MLOps, DevOps, etc. And I believe now you're one of the CTOs of Inner Wisdom, as well as their AWS APN ambassador and evangelist. So I'm going to pass you guys over to Phil, who's going to talk about securing your machine learning solutions and protecting your models. Over to you, Phil.
Thanks for the introduction. I think that pretty much goes through everything on here. And just to also say, Ipswich born and bred. I was born in Ipswich Hospital, raised in Rushmere and Kesgrave, and still very much a local boy. Raised with my family in the good towns, so very local. And like David said, the main highlight is I also run the kind of equivalent of the AWS user group in Ipswich, which is the local kind of meetup that's focused more on the AWS space. So thank you for having me, and thank you, David, for inviting me to join. And it's good to be here tonight. So machine learning and the considerations around security come in various forms. So you have the kind of the traditional infrastructure and physical side of security. And I'll go through all that in the various sections in this session. And there's also data security and everything in that area, because machine learning models, machine learning is nothing but the data that powers them. So it's important to have control over your data and the security around that. Then we'll go through a bit around actually behind machine learning, the model, how to secure the model itself, and also things around the algorithms behind it. I'll explain some of these terms in a little bit more detail. And then we have model management, and model management refers to more how you look after your model day to day once it's in production and integrated into your product and or your enterprise architecture, and how you maintain a model and you keep it nice and secure. Most of my talk will be AWS centric. Of course, there is Azure and GCP and other clouds out there. It's just the one that I use day to day and know best. So I'll be talking about how some of these things can be done within AWS, but there is probably equal ways of doing that in the other cloud providers. With AWS, actually, when we think about workloads, we generally think around through 5 what we call well-architected pillars. So every solution I design, review, critique, I look at from these 5 pillars. One is operational excellence. That's about, again, how things are deployed between environments, how you handle incidents, how you look at problems. There's cost optimization, because when you deploy anything in any of the clouds, it costs you money as it's going along. So you have to keep tuning, looking into how much your workloads cost. And that's very much true for machine learning, when you're maybe using some of the more expensive options when it comes to things like GPU and CPUs to train your machine learning models. So customization one. There's performance, good old performance, basically latency, throughput, things like CPU and memory utilization, that kind of thing, and how to use some of, depending on which AWS bits of their AWS stack you use, how they affect. And then there is resilience, which is basically fault tolerance, how you cope with availability, redundancy, and that kind of thing. But tonight we're focused more on, obviously, on the security aspect and how to secure workloads. I know you guys recently had another talk by one of my fellow user group members, Alex. We'll touch on some of his subjects, but this will be how to apply them in a more specific area. But we will focus down on security. With security at AWS, and when you're developing stuff on AWS, and deploying stuff on AWS, it basically breaks down to this. This is the security model that AWS gives you, called the shared responsibility. The catchphrase is that they're responsible for the cloud, and then you're responsible for running everything of yours on the cloud. And that basically means that, like every cloud provider, they're responsible for the physical security. So they're running the data centers around the world at all their different locations in the different regions, and all of their global backbone to support that. So they're very much responsible for that and how it integrates with things like the internet. And then above that, they, like any cloud provider, give you the compute and the networking architecture for you to, and constructs to build up upon, that they have secured. And the main construct in that area is basically locking you down, so that whilst you're in a multi-tenancy environment, you're isolated from your next neighbor. And then you're responsible for deploying your stuff in the cloud. So you're responsible for encryption and making stuff. They provide you the tools, but you're responsible for the encryption of communication in transit, also encryption at rest. You're responsible actually for your network traffic protection and your network security. And then above that, if you're using instances and servers, you're responsible for the OS, making sure they are patched, making sure that you only grant appropriate access to them, that you lock them away behind things like the firewalls and the kind of network controls that AWS has. And then on top of that, you have access and who can access what, and that they have identity and identity access management built in, and you got access through that. And then on top of that, you have your actual data, where your data resides, your running application, and everything else it uses. So you're very much responsible for what you're running. Now, we'll talk about things like managed services and serverless parts in this talk. Basically, that when you talk a managed service, you're basically moving it up the stack so that AWS are more responsible for elements of the stack. So when you are doing a managed service, they're responsible for the operating a network and that kind of thing, but you're still responsible for the application. And when you move to serverless, you're literally just responsible for the code, and that's all. So that's generally the AWS model to think about when to go through this talk. The four main constructs before getting to some of the more machine learning things, to the basic things, is AWS Access Management IAM, grants you access into the cloud, uses actions and resources, and you must use least privilege to limit what people can do. So only give people distinct roles that can do distinct things with distinct resources, and follow that model. S3, and Alex might have talked about this. S3 is always one of the things that catches the news. You would have seen Capital One and others that have left their S3 buckets exposed, and there's been some sort of data breach of your information out there. That is normally due to misconfiguration. There's lots to do in that area, and specifically when we talk about some of the data used by machine learning, some of that is your most precious information and precious data you have. So make sure that you encrypt your data and you lock down who can access it through using resource policies, and then have the auditability around logging and versioning. Linked to that, encryption. The AWS have KMS, their encryption service, that allows you to use their keys or your custom keys. I'll talk a lot about custom keys during this talk at certain points. Basically, that means that you can control which keys that can be used for encryption. And then behind all of this is the network level, and basically most of the network level in AWS is done at the VPC level. That provides you IP4 and IPv6 networking with controls around network access with NCLs and security groups that act as firewalls, stopping traffic from entering or leaving your network as you desire. One key thing we'll talk about in this talk is private link and how to use that. And that basically, that's a very common thing that I see that people don't use. Basically, you deploy everything inside your VPC, inside your network, and then maybe your machine learning model or something needs to go and access the data in S3. And when that private link in place, basically it goes back out to the public internet and downloads out of the public internet for you. So private link basically means that when you're using some of the AWS services, it sends it through the AWS backbone, not through the public address range of AWS. Okay, so machine learning is a product of the data and the logic. And if that data is wrong or is unsatisfactory, it will impact your predictions and become some of the threats that have. But it's very important to realize that it's not just the algorithm, which is the software that constitutes the model. It's also the data and that model is trained on that data. So it's definitely a point of where you can actually get into what your data is and understand some of the things that drive your data. So that's very important from the view that it's your uniqueness, but it's also one of the ways that it can be attacked, because it's obviously will show you how some of your data is used. I'll come on to that in a bit more. The source of the data and understanding also what's in it is quite important. So not just what the model does and what the model is. Behind that, you've deployed a team, normally of data scientists, that have explored your data, with maybe data engineers that have brought your data in, spent time ingressing all that data, making it available to you. We'll talk about that a bit more in a minute. And there's been lots of time, and I've been involved in projects that can take 3, 6 months, a year to produce. So you've invested a lot of time to make get that model available to you, and you don't want someone to come along and steal it, or steal the secrets behind it, or steal the knowledge of what's in that data, and not just go and steal it, but mitigate all that hard work, all your investment, and you want to make sure that that investment is sound. Also, with a lot of machine learning use cases, they may use PPI and PCI-DSS data. So it's making sure that if you're using personal information or payment information or anything like that, that securing the data is essential, and it's an important consideration about securing your model, because you have requirements under GDPR. And there's other things I'll talk about in that space in a minute, but it's very much, you have to think about the data you're using. So you have to safeguard your data and put appropriate safeguards around it. And one important thing is to separate kind of your analytical space, where you're doing machine learning and other advanced analytics and maybe BI, from operational workloads, to make sure that people can't interfere with each other and that there's clear isolation between the two. Another kind of very important thing to think about in machine learning is where in your machine learning training large data sets, you're going to be using multiple servers to do that. You may be using things like data pipelining, GPU pipelining, which are basically ways of maximizing the throughput through a GPU or CPU. And you've got lots of parameters that you're passing to these models, so they require quite a lot of compute power. So you might be using multiple CPUs and GPUs on the same instance. So you've got data exchange going between those GPUs and those CPUs through buffers, that kind of thing. So again, in a multi-tenancy situation, you have to watch the security there and make sure that you are isolated. So data is going securely across boundaries. So some of the ways that we address that, and I see implemented every day, is to really control your data posture and how your data is, where your data is ingested and how it's used. So the core kind of technology phrase we use in this area is data foundation, and that is about making your data available and that make sure that it's secure. You also need to make it comprehensive enough. So the whole point of having your investing time in forming a secure data lake is that you also offer up that data to the data scientists and the analysts and the people that need to use the data to get these deep insights. So you need to have it secured, but also a clear lineage around where it's used, how it's used, where it came from, when it's last updated, and also clear classification of data, particularly if it's containing private or personal information, or it's containing payment information, or maybe extremely confidential to your business. So it's important to have all of those built into your data architecture and into your data lake or data warehouse, whatever you're choosing as your kind of your data layer and foundation, is make sure that you have the appropriate structures and rigors put into that. The key thing that we see is using data layers or virtualization. So once you have characterized your data, especially in the raw data, the layer is making sure that you have multiple layers. And we normally see 2 or 3 layers of the raw data, then it's been sanitized and then optimized for usage. And there is now alternatives coming through virtualization, such as DBT and that kind of thing, but it's still very important to structure your data inside your data lake, your data warehouse, and then control the access to each one. But again, it's amazing every time I have to say to some people, is like, if you're using, if your data has got PPI or payment information in it, and you don't need to use it, then just get it removed. And that's why that sanitization is quite important. Just don't have it exposed to your model, so your model can't learn it and it's not part of what it does. Just remove it and sanitize it. But if you do need it, then have complete auditability on its use. The other thing, and we come why this is quite important, is putting validations on source data as well. We want to make sure as data is changed or new data comes available inside data lakes, that they come available to the machine learning and that they're valid, and that we spot any problems with them as well. So if it is tampered with the data and trying to influence the models, and we come to some of the theories behind that in a minute, that we want to put the appropriate checks in place. And lastly, as I was mentioned before, there is on some of the, especially AWS as well, when you're doing things like GPU pipeline and data exchange, they have worked out some of those multi-tenancy concerns for you. So if you're using the right additions, you can securely communicate between the GPUs on one instance when you're doing some of those bigger and more complex models. Behind this, so these are some of the technologies that we use at work, and I've seen on AWS that help you do that. So going back to S3, I obviously mentioned earlier, the typical way we see that used is to build out the data lake. And again, make sure that you're using like a multi-bucket and multi-folder structure to that lake, building those, like I said before, those layers, and make sure that you promote the data, and keying back to KMS, make sure you maybe encrypt it differently. So have different encryption keys for the different layers of the lake, or if you're doing a multi-tenancy solution, then encrypt different tenants' data using different keys and using different folders. And the part of that, when we're doing data warehousing, is Redshift. Again, so Redshift has the notion of multiple schemas, multiple database and schemas. So make sure that you are putting appropriate controls around that in a multi-tenant environment using multiple schemas. And then if you've got to deal with different layers of categorized data, make sure that you have a raw or staging area at that, and then a sanitized layer, and then the kind of the optimal layer on top of that. So make sure that you structure them and you create them correctly. And then in terms of how you do that and how data is processed through these data layers, then there's a tons of options in AWS and other cloud platforms how to do this. Two of the main ones is EMR. So that's basically a managed service. So I mentioned the shared responsibility model. That is about them. They stand up all the servers for you and run Hadoop for you, and then basically you submit your Hadoop jobs to the cluster. The advantage of that is that it has access securely to EFS, which is a storage solution, block storage solution, or to S3 again, where you can store your objects. The advantage of that is that with that Redshift and Glue, they all can run inside your actual network, and that's quite important. Make sure that you are running inside that VPC construct that I mentioned earlier. Make sure that you have layers to your VPC, and that you have your data locked securely away in the most secure private layer of that structure. Glue is very similar to EMR. It's just not Hadoop. It just runs PySpark. So it's a bit like Databricks for you. If those who use Databricks, it has a lot of native integration, particularly with S3 and Redshift. The two advantages it has is it automatically has included these days, and you can build out to it a Glue data catalog. So that's that lineage and understanding how your data is used and where it's come from, what's inside the data, and its characterization. So make sure that you use something like Glue, and that's also can be used as a EMR meta store as well. That's compatible with EMR for that. So Hadoop can use it as well. And you also these days have lake formation, which is another level access on buckets and Redshift that Glue has, that you can restrict down to row level access to and table level access to what can use your data, and column level access. So it gives you quite finite controls of who can see the data. So that's data. That's also really important in machine learning. The other half of that is your algorithm, and again, it forms the uniqueness that is your OSP. So it forms the algorithm. So algorithm is the neural network, or the linear regression, or the that kind of thing. Typically, in most situations, and particularly in supervised learning, I can explain that a little bit in a second, that you use a publicly available algorithm that's available out there, and you may have heard some of them, like scikit-learn or TensorFlow and that kind of thing. You train your model on that data, and with high parameters, you'll tune it. So supervised learning is you label a data set. So if you have a banking fraud data set, you label your data set up, which one's a fraud, which one's not fraud, and then you run your model over that data, and it trains on that data, and it produces the trained model as an artifact afterwards. And the algorithm you selected there is probably scikit-learn, a linear regressor, or maybe XGBoost or something like that. It doesn't really matter too much unless you're getting into data science which one it is, but it's a framework that understands that data, and you train it on the data, and it makes it unique to your model, unique to your data, and then you can go and predict your banking fraud or whatever you want to do. That's typically a very supervised learning problem. And then you have unsupervised learning, which is more clustering. Typical example of that I see is address data. If you've got loads of address data in your system and you understand how unique they are, and maybe you haven't got all of the postcodes and all the full addresses, you can use a clustering to understand, and a tokenizer like Levenstein distance to understand how similar in terms of addresses they are in terms of the string kind of similarity of the address. And you can cluster them together and understand when a new address comes in the system, which one of the clusters it most resembles. Again, in all this situation, you're using mostly your data, but you could be using a public algorithm, or in some regards, you're kind of developing your own algorithms. And with clustering style solutions and unsupervised solutions, it typically needs to be the latter. So you need to store the code somewhere of your algorithm. So storing your code is also quite important, and we focus that in a few minutes. But they're the main two. So there's also reinforcement learning, where, but that's something I've not had too much experience of. But that's where you can train it on like the price of the current price of an airline, and if it goes up and down, and that's evaluating things based on a reward function. So like the algorithm is quite important, and if it's a custom algorithm, or you write a script that is for the public algorithm but implements the different layers and stuff, you need to keep that code secure, because that's going to be, you definitely use that again when you retrain your model, and it's important that you keep that locked away, because that includes sensitive information about what's in your data and how it's used. And then to link to all this is the other complexity general in data science and machine learning is data scientists by position are experimental beasts. And I love them. I work with loads of them, but they are quite experimental. So you have to give them kind of the overall rigors and engineering to allow them to experiment and deliver their stuff at scale. So lots of my other talks are in the MLOps area. But in terms of security, what you want to do is you want to make sure their data is available to them where possible. You want to support them in terms of storing their code away securely, and but still give them the ability to experiment. So you have to provide that balance to the equation. And then kind of linked to that is CI/CD, and making sure this comes into the MLOps, which is another phrase basically of how to do CI/CD for machine learning. And how to build and how to train models securely, have processes around how they are built, how they are trained, and how they're deployed, have the appropriate safeguards in place of who can approve models going out into the wild. Make sure that whilst you want your data explorers to experiment, you don't want them to be able to interfere necessarily with production or down your production system. So a lot of that is having segregated environments like dev, test, and prod, where you can control the different access and how much they can interfere or get into the system. And then, of course, you just want to be able to keep their code securely away. They tend to use a thing called a notebook to do lots of their development in. It's kind of like their IDE, but you have to make sure that is saved, backed up, secure. Again, that's stuff you've invested time in, so you want to make sure it's securely locked away with the appropriate access in place. To do that, we kind of use a number of technologies, and they focus around Docker. Most of the runtime training is Docker. The reason why we like Docker generally across the board is the isolation and separation it gives you from the runtime versus what's actually there. So from operations point of view, it's good, that clear separation. And then make sure that you can store all your machine learning code and everything you need to, those notebooks and everything, into things like Git, and make sure that you have your Git access, and you have appropriate controls and secure development controls and life cycles around who can approve, and make sure that you look for you do analysis over that code. So security scanning and static analysis is quite important, especially as we get production workloads further out and fully deployed, and you need to make sure that they go through that CI/CD pipeline and make sure that you're applying order again and scanning it for both security best practices and also vulnerabilities inside data packages. Generally, I see that their scientists will just kind of do what they need to do with the dependencies, but there'll be a myriad, and they'll need a bit of control and a bit of also particularly looking at around licensing and making sure that everything is Apache 2 or MIT or whatever appropriate, to make sure that they're not using something they shouldn't as well. So you have to make sure that you are scanning for that kind of thing, and also you have governance and controls baked in through licensing. The best way of doing that is using private repositories, so using GitHub and private repositories, and there's some other AWS tech we're coming on to in a second. Also making sure that you're using private things like a private Docker registry and a private artifact registry to store your images and your binaries and everything in. In AWS, basically where machine learning really starts is a thing called SageMaker. SageMaker is their AWS suite for machine learning. It's quite big these days. It's more than a service, it's kind of an ecosystem, but what they do is specialize in a number of areas, and we'll just talk briefly through some of them and the most relevant ones today. So SageMaker pre-processing allows you to run a Docker image. The important thing is what that allows is for your data scientists to be able to securely run their feature engineering code inside their VPC, and it gives Lineage about what they run and when they run it and what data was produced in and out of maybe S3 or EMR. Feature engineering is basically the magic step between having your raw data that I mentioned earlier and doing something with it that a model understands. So the data scientists have to go through a process of applying logic to that. So it may be that it's encoded in a certain way, or it's combined with other features, other data to make a good feature. A good example, if anybody's ever looked at it, is the Titanic data set. You don't really have a class of cabin in that data set, but if you know roughly the location on the deck and which deck they are, you know which and how much they paid, you know roughly what kind of cabin they had, and depending on the cabin is the biggest proxy for the class and the survival, basically. So if you look at some, and that's kind of how you can take maybe two or three different data points and combine them to create a feature for your model. Again, that knowledge of how to do that is your IPR, and also it could be using some very private personal information to your company or your person. So it's important to have those controls around who can run it, where it runs, and that kind of thing. SageMaker training basically is what I spoke about before. It's taking that algorithm and your data and then running that over a server and training a model and producing a model at the end of it. And SageMaker provides that GPU and that data parallelism support that I mentioned earlier about encryption between multiple chips and also encryption between instances. So if you deploy it inside your own VPC, there would be security talking just in your network, but also over HTTPS. And with batching endpoints, they're basically how you can serve your model. Again, you can serve that inside your private network in terms of VPC, and it can access your secure data and your data stores and your repositories. The most interesting one, I'll come more to this in a second, why this is relevant, is also things like model monitor and clarify. These are more things, ways you want to monitor your ML performance. So what you want to understand is overall accuracy, and that has a play into when you need to retrain. And I'm not going to go into that in this talk, but that's a different subject. But it also kind of tells you how important all your features are. And it also tells you how biased your features are. So if people are attacking your model, you can, and some of the threat types I'll talk about in a minute, when when they start to attack your model, you can see a deviation from your baseline that you maybe achieved during training. And if that deviation happens, then maybe you need to look at that. Just behind some of those kind of, I mentioned a lot around MLOps, CI/CD, that kind of thing. Hand on heart, some of the open source offerings are better than some of the AWS ones. And the two kind of, this is where maybe it is. So AWS have ECR, which is a private Docker image repository. That is pretty good these days. It also has built-in vulnerability scanning. So if you upload your machine learning container with your algorithms runtime in it, then you can scan that and scan all your private dependencies. So like when the Log4j incident that happened at the start of the year, we were able to scan inside all of our machine learning models or all their runtimes to see if we had Log4j anywhere within the image. And then you have code artifact. It's a bit like Nexus. I do prefer Nexus problems, and that's basically where you can save your wheel file that's produced, or if you're Java, it's your jar file. Your Node, it's your node zip as well. And the good thing though is that it supports the auditing of dependencies, so you know who's using what. The bad thing is, and this is where some of the, particularly the Nexus offering is better, is that you can't, it doesn't have approval built in. So if you want to approval, you need to probably use Nexus or Artifactory or something like that to store your code artifacts. Code commit is basically Amazon's Git. It's okay. The good thing is it combines with some of the other AWS security scanning, so you can scan it, or you can deploy SonarQube yourself to scan it. However, it's okay, but it's not as good as GitHub. And most AWS services also support GitHub that need to for CI/CD or whatever, and SageMaker as well. So it's available. I do use it every day, but at the same time, I generally prefer GitHub. It has a lot more sophistication around PR and approvals and scanning for security purposes. And code build and code pipeline, they're CI/CD capable in AWS. Capabilities in AWS, you can use them for implementing your ML workloads. However, Jenkins with GitHub is generally better. The main thing around using something like Jenkins, however, it's going to be that you have to set up the server and run it yourself. So it depends on if you want that, and then you have to patch it and maintain it and everything around that. So just bear that in mind. So some of the machine learning threats you face are kind of these five beasts. Model poisoning. So model poisoning is about a specific attack around putting, and this is very common where you have a feedback loop in your machine learning where you're taking things that are given, is where you're putting data deliberately into the training data set. Remember when I was talking about supervised learning, to interfere with the model so it makes different decisions. A good example of this is kind of TripAdvisor or Amazon, when you submit all those feedbacks and there's all those fake feedbacks that push up the score and that kind of thing. That's a good example of where people are trying to put erroneous data into the model to make a prediction of benefit or discredit it. Okay, so it may be that you can't directly benefit from it, but you can make people don't trust the Amazon reviews. Like most people don't trust Amazon reviews or TripAdvisor reviews because that loads of them are fake reviews. So there's lots of efforts in that area, and the important thing is to invest more times into looking at what's good and bad. However, to be honest, no one's cracked it, right? Because TripAdvisor and Amazon still have fake reviews, so it's still a kind of evolving space where someone will come up, hopefully, with the crack to solving it. Knowledge transfer is a bit clever, so it comes back to some of those points I was saying earlier. You spent a lot of time developing all your model, and you've invested lots of time, people's time in doing that, and it's something really important to your business, and it's probably at the heart of your business. If you imagine you're maybe something like Google, Spotify, or something like that, you spent hours on your search algorithm or your recommendation algorithm. And then what can happen, someone can come along and not even steal it, they can basically copy it. So if you know the inputs, or enough inputs to the model and enough outputs at an API level, you can attack a model and vary your outputs randomly and work out basically what that model does and replicate that model, maybe using a less complex model. So for example, if you're doing lots of image classifications, that kind of thing, you may train a very deep neural network to do that. But if you are if you use something called knowledge transfer, you can train maybe just a simple classifier at the top of it that replicates the same thing. So there is some techniques to combat it, and the key is to have lots of regular updating data that you need to, and those deployment processes to deploy them to make sure that you keep updating these models. And it's also, it can also work as a benefit to protect your model as well. So some people do train a deep learner, and then as a countermeasure, then we'll train a knowledge transfer and put that basically as the actual production model, and then protect the primary model. And the important thing is that you can use it to understand. So for example, if you're using something that's analyzing what's in text, and you've built something that like address data that knows what's in the text, if you copy the model enough, what you can then do is reverse that model and get out what the original data was. So it's possible to get back to things like the original data that's there, or enough about it for it to be of damage. Or if you're using an image, get back to the maybe if you're doing photographs, get back to the person, or enough of the person to be able to recognize that person. So be very clever and be very controlled around detecting that. And that's where some of those you can use some of those other techniques. Model evasion is again very different. So if you'll know that someone's got a machine learning model and they're providing you a recommendation, if you've spent enough time exploring around it, you may be able to inject enough noise or know exactly where to push the neural network so that you get a different classification. So a good example of this is there's in some of the kind of PhD papers, you can get a penguin, and if you a JPEG, and if you just put enough noise in the right place, you can, and you've got something that's trained on a whole different series of wildlife, you can get it classified as something completely different. And it's, to the human eye, you can still tell it's a penguin, but it can be of it can misdo. So that's where some of the model detection techniques, where knowing if a feature is being overused or something, or deviates from how it is trained, then you know somebody's kind of attacking that. And then kind of model extraction is normally used with the other techniques, and it's basically going down, and you can with some of the networks, you can start look inside it and work out what the weights are by not just white boxing a model. You can kind of start black boxing what's and systematically looking at, so why did it categorize a penguin? By changing maybe bits of the image, you can kind of start working out why it classified. Or if you're using it on other data, you can kind of work out why that is. Normally used in conjunction with the other attacks. And then the last two are kind of linked back to kind of those that kind of knowledge transfer thing. Is if you have trained data on a lot of personal information, then you can interfere with it, work out, if you're using knowledge transfer, you can work out the delta between the original model and maybe what the secondary model was. You know, that delta, you know, that is specific. So a good example of this is if you've on image classification, generally what you're doing is using knowledge transfer, and you'll have a general model that's, you know, routines of hundreds of images. And then if you want to train it just to recognize me, you then feed it 10, 20 models, which saves you, from a data science point of view, a lot of time. But if you can work out systematically the delta, you can then get back to recognizing me. So it's very important to that. Another good example of this is kind of, I've seen this like on Google and other places, is like autocorrect. When people implement autocorrect, it can be quite easy and to start kind of being exposed to data leaks in this area as well. So lots of if you're using PPI data in your system, for example, and you're maybe using a kind of multi-tenancy machine learning solution on top of it, make sure that you exclude your PPI data, so it's just not in your data set and it can't be included. It's a bit hard when it's things like a fraud detector, but maybe in a recommendation engine, that kind of thing, just don't include the actual identifier information. So I've seen that a lot in kind of emails and that kind of thing, where it starts trying to guess, and sometimes it will guess with people's names and stuff, which is scary. Another interesting thing in the general space is regulation, and I'll just briefly go over this. Is regulation is coming to AI machine learning. This example is European Commission. They launched a white paper proposal last year. The UK government has also launched their AI strategy. It's a bit more wishy-washy because it's our government, but generally AI is becoming more regulated, and that poses some challenges as well, specifically the EU ones. And we have to remember, like GDPR, etc. It's not just doing it in Europe, it's doing for European citizens, so it will affect us as well. The main thing is they have lots of control in this white paper around high-risk AI systems, and they're basically ones that can affect individuals, basically. And you can see on the side things like identification and education, employment, and law enforcement, that kind of thing. So if you're doing machine learning in that areas in Europe, you're going to become highly regulated in the next 5 years. And if you are, I encourage you to read that white paper, but you need to make sure basically you cover things like explainability, which I'll come on to in a second in the final few slides. And this is about model management. So once your model is live or and out there, but it's about how you protect that model when it's live. And I mentioned before things like MLOps, but it's also securing your features securely, make sure they're auditable, make sure you're storing your models securely inside a secure location, and that you have secure access to all of those. So examples of things you can use in this area is a thing called a model registry. So this is a bit like a private, I mentioned the private repositories before. This is kind of the ML tooling implementation of that. You normally, and I'll command it in a second, you normally base it off those other kind of constructs. But it's about securely storing your trained models away, that you version your models, and that you have auditability around when and how they were trained, so that you can, if you're facing an attack or regulation, you know what it is. And there is a thing called a feature store, which is the same but for features. So understanding storing your features, understanding where they came from, what they were being used for, how they were made, who made them, when they were last updated, what models are using them. And it's just all that like lineage and accountability. And then what I mentioned before was model biased and drift. So detecting when your model either is being interfered with, and so it's drifting away from the features that it's trained with, or biased. So again, if you're doing in law enforcement, and we see cases of this in the news every once in a while, is you'll see models that have maybe historic, but because it's been trained on historic police performance, it can have by itself race biased in America, or it doesn't have to necessarily be America, but racial bias built into the model because it's a supervised subset that's used in the real world. So you have to detect that bias, and then you have to take countermeasures of oversampling the minority classifications to do that. So it's important to have some of those bias detections in, especially if you're in regulated markets. It's going to be that. And all this provides kind of explainability into your model. Just to provide a little bit more detail on that. So model registry, basically, you can see some of the constructs I've always spoken about. It's about, again, it's just about having meta information about storing your models in S3, storing the images in something like ECR Artifactory, having the code securely kept in code commits, and then managing the progression of metadata around that, and who approved what model, what path did it take to get into production, when it was used, what features were used, and how it's updated. And then model lineage is basically the feature store. It's linked all to that. Is basically understanding, again, what features were used, how they were stored, how they came together with your algorithm, what algorithm you used, was it an approved version, that kind of thing, and that gives you that lineage into your into what's happened to meet either regulation, and you can also understand any attacks or any countermeasures you need to put in place for attacks. And then basically, when that model is concerned, you need to put it behind secure APIs and then secure orchestration. A good example of one way of counteracting some of those model ways of stealing your model is, and it has to be a property of the model, but it's when it's using hot data as well as historic data. So some of the solutions I have worked with is it's bringing in maybe current availability or stock level, that kind of thing. But the more of that stuff you that more kind of recent data you introduce into a model that has its own expiry, means that you have to have the ML ops bit, but it means that the model is changing and you're redeploying and the data is changing. So it just gives a kind of a moving data point to attack against. And that's really it. The only other thing I briefly want to talk about before taking any questions was part of the reason why Dave invited me was, I'm on the AWS user group in Ipswich. We should be having a meeting very soon. I just wanted to also just extend an overall invite to everybody here to come, and especially the Ipswich people. We are trying to do it in person. We did one last year in person, in between all the very different, complexities around what you could and can't do. We did an in-person event. We booted it during the pandemic as virtual, and then we did our first in-person event. We have 20 to 30 people, and again, we meet three or four times a year. So if you want to learn more about AWS and things you can do AWS, then there's an open invite for everybody to come along. I should be publishing soon. Again, it's up, join on Meetup or watch on AWS Ipswich on Twitter, and you can see when we next meet. And that was it. Any questions?
Thanks for that, Phil. That was very interesting, very comprehensive. I found it interesting on the slide about you started off with the model poisoning and knowledge transfers, etc. It was, different names or words for the same techniques that we've come across many times. We would call it injection, cross-site, brute forcing, and fuzzing. But yeah.
I agree, and that's a lot of thing that I'm seeing in the machine learning space. Like with ML ops, it's the DevOps, it's security, it's all those good things with a kind of a new twist. As you always get a new twist on it with specific things for that specific domain. But if you fundamentally know security or DevOps or software engineering, etc., those fundamental principles, then you can apply them to some aspect of machine learning, because machine learning is so much more than just the model. You've got to have all those other disciplines in place.
That's great. So is any questions? Anyone got any questions?
That is a good question. So the question is, does Amazon provide similar resources to threat modeling in Microsoft? So it provides some sort of like detection and protecting systems. They have Guard Duty, which uses a bit of machine learning to look over all of your logs that flow through your system to understand if there's a threat emerging. They have Security Hub, which is about compliance. So, for example, S3 and encryption. I want all my buckets and all my data to be encrypted. I can put in a rule in that says it must be encrypted, and it will flag me if it's not encrypted. And then you have things like they're all kind of similar but not. You have Trust Advisor that can also advise you when to improve certain aspects of your security. They also have network detection as well built into some of that stuff. What could have a shout out to one of my colleagues. So one of my colleagues is, and I think David knows, Asa, is very hot on that that side of it as well. He might be able to give a more specific example or talk on that kind of thing. But AWS do have some of those offerings in place. Yes.
So I'm making a note of that, and you're volunteering Asa to talk.
He'll love me.
He will, won't he? Yeah. He's your security guy, isn't he? So
he is, yes. So yeah.
I'll rough him in, definitely. I will chase him. Anyone else?
So it's kind of building on what Dave was just saying, that it is interesting the way that a lot of these things seem familiar but have different names. And so is it very difficult because of that to be good across all of the platforms? Or is this something where there's a natural specialization because you get so tied into the jargon for a specific cloud provider?
So I think there is definitely cloud provider specific jargon I use, but things like the model poisoning and some of those more those conceptual things, they should be generic and applied more widely. And for example, like the model registry, I gave an example of how you can implement that using ECS, S3, and Dynamo to keep your meta, but you can equally probably do that in Azure using their equivalent, or open source using open source equivalents as well. So those concepts I think are very generic. They are quite I say new. They're not new. They're like, again, in their own right, like machine learning itself is ages old, and yes. some of those concepts are like, if you look at the papers, they're at least 5 years old. But
yeah,
the strange thing is, like with machine learning, it's only now that all these things are coming to fruition, with the hyperscalers being what they are and making machine learning more available, and suddenly people are going to worry a lot more about the securing of their models, because suddenly they realize that they're investing a lot more time in these things. So it's like, it's only now that these things are being applied in the real world, not just the academic world.
Yeah, the stuff on modeling was interesting. I hadn't realized that there was a lot of borrowing, theft, influencing of stuff where yes, the models are obviously there's lots of time and effort invested in them, and so I hadn't realized that there were people who were actively trying to steal things like that. So that was interesting.
Good.
I had a question. So when you're categorizing data and you kind of got the different categories, is it just, how do you kind of police that with policies across AWS? So like we use GCP where I work.
Mm-hmm.
Is it just a matter of like communicating with your colleagues just to work with things, or is it a case of just, are there any like kind of open source tools to help police different categories of data? Because we've got payments data in our platform. And we want to be able to police access to that and manage that.
Yeah, so there's a couple ways of like securing that fundamentally, like within AWS. So if you're using S3, when you create a bucket, it's a bit like, I think it's the object store in Google. You can set up specific tags on it. You can make sure when people use that they have to have that tag set when they want to put something into it, and that tag can have a specific categorization to it, or if it's sensitive or payment data or personal information data or company data and that kind of thing. So you can control it through that kind of thing, and then you can use things like Google Data Catalog to reference that and know what's inside it, and know what's inside your data lake and who can access it, and then limit the access based on that. So you kind of have to design it in to how you do stuff, but the controls are there so that you can then limit it. And I've been in very prescribed environments in AWS where you can only upload it through the recognized channel when it will
I was just going to say, did you run out of space?
I did think I ran on a bit long, but
Yeah, the 200,000 hours. I didn't think we'd used up all of that. It was, how weird. Yeah, it just stopped for some reason.
Time runs for different people in different way. So
Didn't quite get that, Wojciech. Is there any more questions for Phil? Feel free to type them in the chat if you don't want to speak, or if you don't have a microphone. No, I think your talk was very comprehensive, and you've covered all areas.
thank
Great.
you.
I might have a question, but it's a little question.
Okay.
I don't have anything to ask you till now, but I'm trying to have a look at machine learning anytime soon. Hopefully, it's on my bucket list. If I have any questions, can I approach you?
Absolutely, no problems. My Twitter and everything was on the first slide, but yeah, feel free to reach out. No problems.
Brilliant. Thank you very much.
I'm assuming that bucket list is the wrong metaphor to use to someone who uses AWS.
I was going to say, yeah, before I die, I want to learn machine learning.
Yes.
It's only good if it passes the Turing test and it becomes you, and you can live forever in the cloud.
Yes. Presumably, you store a bucket list in a bucket.
Yeah, 3 buckets.
Yeah,
Yes.
not S3, no.
Yes. This ends today's AWS stand-up. Yes.
Okay, I lost my track there. So if you could send me a copy of your slides, Phil, I'll distribute it to everyone. And it's got your contact details on there, so if anyone wants to get in touch with Phil, got any further questions, feel free to ask him. I think we'll end it there. And thanks for coming on, Phil. Thanks for giving us a great talk.
Thank you.
It's very informative. And thanks everyone else for coming along. And hopefully we'll see you at the next OWASP Suffolk talk. And don't forget to check out the AWS user group as well.
Cool. Thanks, everybody.
All right,
Bye.
bye.